All right, everybody, welcome to the video here for lesson number 2 on the division of polynomials. So in this lesson, we learned how to do the reverse tabular method to find all of your quotients. So let's take a look at the first one. So remember, the denominator of this fraction, or what we're dividing our expression by, that always goes on the outside of your box. So I'm going to put 2x on the outside and negative 3 on the outside, and then I'm going to make my box go across. The first thing that we're going to put in our box is the first term we're trying to make, so that 2x cubed. Well, if that's the case, I need to multiply 2x by x squared to make 2x cubed. And then using those puzzle techniques we talked about in class today, right, just looking at things, we can say that that box becomes negative 3x squared. Well, that box added with the next box above it to the right has to make positive 1x squared. So I'm going to make that 4x squared, making this top number 2x, or that top term 2x, which would then in turn make this 6x. And these two boxes together need to make negative 16x. So I already have negative 6x. So I got to add negative 10 more to make negative 16. And that would cause us to have a negative 5 here, which would make this a positive 15. Remember what we said in class, this number and this last number for today should match, because nothing that I gave you here in the homework should have a remainder. So my final answer here is x squared plus 2x minus 5. All right, let's take a look at the next one. So same thing. So I'm going to put my, I'll get rid of this for now. Let's move it over here. So I'll put the x and the negative 2 there. First term I need to make is x cubed. So I know the first column is going to have an x squared in it. The next thing that I know now, because of my puzzle skills, is that's going to become negative 2x. But I don't want any x squareds, right? I want 0x squared. So I'm going to make this 2x squared, which will cause us to make this 2x. And this will become negative 4x. But I don't want any x terms. I want 0 x's. So I'd want to make this positive 4x, that those would cancel, which would make this 4, and this negative 8, which we see there works. So then we have x squared plus 2x plus 4 as my answer. Now, the only thing to honestly make this more challenging is to make it so it has more terms. The actual mathematics behind it, though, is pretty straightforward. So looking at this next one, I noticed that the middle term, the x term, is missing. So I'm going to actually make 3 rows, even though there's only 2 terms there. The first thing I want to try and make is 3x to the 5th. I'm going to make that by multiplying just by x to the 3rd, which means I need an x to the 2nd column, an x column, and a constant column. So now I know how many columns I have. I know all of these are going to be zeros no matter what I do there because of the 0, but they're there as just kind of like placeholders, and this is negative x cubed. Now, the next term I want to try and make is going to be 12x to the 4th. There's my x to the 4th term, so I got to make this one a 12x to the 4th because I have nothing in the other box. So that would be multiplying us by 4x squared, which would make this negative 4x squared, and then we could keep going. My x to the 3rd term, so these 3 boxes are going to make 11x to the 3rd, so I need to make this top one 12x to the 3rd, so that 12 and negative 1 can make 11. That's going to make this negative, oh, sorry, got to do the top first, so that would be 4x again, so that would be negative 4x. And for my x squared terms, I need to make 2x squared, which would make us having to make this 6, because 6 and negative 4 would make 2. That would make us multiply this here by 2. And this would become negative 2, which works. Everything works out. So my final answer here winds up being x to the 3rd plus 4x squared plus 4x plus 2. The next one, before we go on to that last problem there, again, we have 2x we have 1. We make our rows. First thing I got to put in here is 4x squared, which would make us multiply this by 2x, meaning there's just a constant term. That's all the columns we need. And that will become 2x. I want 8x, so I'm going to put 6x here. That makes 8x. If I do that, I make this 3, and this becomes 3, and we check. So this becomes 2x plus 3. All right, so hopefully we kind of reviewed that skill for you here. So let's see what this last question says. So it wants us to compute the quotient, right, just like we did above, and express that quotient or that polynomial, that cubic polynomial, as a product of two polynomials. So this goes back to what we were spending a little bit of time talking about in class today, right? Understanding that when I do this division, I'm getting a factor of that polynomial, right? I'm not just getting a random thing here. Right? So when I put 3x cubed in here, right, that's going to give me just x squared. I'm going to get negative 2x squareds. I need to make 10, so I got to make this 12x squareds, which is going to cause this to become 4x, which is negative 8x here. I don't want negative 8, I want negative 4. So I'm going to make this box negative 6x. If that's the case, that becomes a negative 2, which makes this a 4. Everything works out. So what this tells us is essentially whatever is in these boxes can be represented as a product of these two things or these two expressions on the outside. So when it says express this as a product of two polynomials, that product is 3x minus 2 and x squared plus 4x minus 2. They're the factors of this polynomial. So when it says explain your reasoning, you're saying if you were to multiply these two polynomials together, you would get back that cubic expression. Hopefully this video helped you complete your homework or review your homework, however you looked at it or used it. Keep watching them. I promise they'll help. Those of you that had me last year in geometry, hopefully you used them last year and you're continuing to use them this year. If you are new to my class, I hope that you use them to check your work, make sure everything's good so that we can keep going here and have a great school year. All right. Best of luck, and I'll see you all tomorrow.